Hello, everyone. You're back. I'm so glad you're back. We've learned how to graph lines, I guess, using sort of two different methods, although the intercept method seemed really similar, right? They just were more specific. They didn't say, pick whatever values you want and plug them in. They said, here, use these certain values we want you to use and plug them in. So kind of the same method, it's just one got more specific. They said, all right, we're experts. We know what the best points are to plug in, so do it. Which I kind of like that. Then there's no guesswork or no, I won't forget how to do it. I know there's one way and there it is. And this section here, it kind of seems off topic because there's no line. We're not graphing any lines or anything. But it's gearing us up for the third and final method on graphing lines. And if you're thinking, oh my gosh, another way to graph lines, this is a good method that we'll see in the next section after this. It's good because I guess when a line looks a certain way, which we'll see what that is, when it looks a certain way, it's easiest to graph lines using slope and y-intercept. And if those don't mean anything to you, don't worry, they will in the next section. But it's kind of a complicated topic, so this section is just kind of getting us used to what a slope would be. Although in this section they call it rate, because in real life, you don't talk about slopes very much, you talk about rates. If you remember, in the application section we went over, remember we did some distance, rate, time problems, and we said rate in those problems is kind of like your speed. I guess speed is very specific though. It has to be like you driving a car for a certain amount of time, or you walking, or something's moving and you're figuring out how fast it's moving. But rate is more general. So I'd say speed is just an example of rate. What's another rate like? Well, here's examples. Why am I trying to come up with more? Hello. But in general, the definition of a rate, it's a ratio that consists of, it indicates how two quantities change with respect to one another. So for example, miles per hour. It tells you how your distance is changing, your miles, as your time changes. So if I'm driving 70 miles an hour, that kind of, it tells me how the miles that I'm driving and the hours that I'm driving change with respect to each other. So for every 70 miles I drive, it takes me 1 hour of time. So that kind of thing. But there's all kinds of examples of rates, and we'll see them in this section. Believe it or not, it'll help us graph lines. And it'll help us understand kind of word problems better too. So there's a bonus. See, this first example here, just kind of letting you know that this is an example of a rate. If you make, let's say, $10 an hour, that's a rate of pay for an employee. And you can think of it, like they said, it's a ratio. It's not usually written as a ratio in real life, but you can always write it that way. $10 per 1 hour. That's how I would say it out loud. $10 for 4 per 1 hour. But you can write it as a fraction, and it means the same thing. And then we talked about speed earlier. The example here, if a vehicle travels 280 miles in 4 hours, what's their rate of speed? Well, if you write that as a fraction, you get 280 miles over 4 hours. Of course, 280 and 4, those reduce. 4 goes into both of those, and you would reduce it to get 70 miles over 1 hour. And that's a rate, 70 miles per hour. 70 miles for 1 hour. And not all rates have to do with time. I mean, there are some, we'll see it in examples, that have to do with other things. But that's kind of the idea behind this section. So it's kind of interesting. Just, I guess, keep in mind, in all these problems, you're trying to set up a fraction. Something over something. Like that. And they'll tell you, like if they said miles per hour, for example. The first thing they mentioned should be in the numerator, miles. And the second thing, per hour, that should be in the denominator. So they'll always tell you kind of the units they want, miles per hour or dollars per minute, whatever it is. The first thing they mention should be in the numerator. The second thing they mention should be in the denominator. So that's a good way to remember it. All right, I think this is one of those sections where there's not a lot of background to go over before just jumping in, so I guess we might as well just jump into this first example. And this example, I think they might give us some things we don't really need. I don't know. Let's see. They said on February 10th, Oscar rented a Chevy Trailblazer with a full tank of gas. It had 13,091 miles on the odometer. Okay, February 12th, 2 days later, he returned the vehicle with 13,322 miles on the odometer. The rental agency charged, oops, I don't know why I put $2 here, sorry. What does that even mean? $92 for the rental, and they needed 14 gallons of gas to fill the tank. Okay, interesting. So notice they kind of snuck this in there in the beginning. He had a full tank of gas in the very beginning, and then in the end they needed 14 gallons to fill it up. So that means he must have used 14 gallons of gas, right? Oscar used 14 gallons. I don't know if that'll be important later, but sometimes it kind of helps when I notice things, I'll write them down because I might forget them later. All right, let's see. What do they want in part A? They want to find the SUV's rate of gas consumption, and the key words here are in miles per gallon. So that tells you, remember, in these problems, you want to set up a fraction where the numerator is the first thing they mention, so miles, and the denominator has the second thing they mention, gallons. So that's a good thing to remember. They mention miles first. Okay, so that goes in the numerator. Gallons second, so that's in the denominator. And now all I have to do is figure out what those numbers are. How many miles did he drive, and how many gallons did he use? Well, actually, the thing that we noticed earlier over here, he used 14 gallons, so we know that right away. That's kind of nice. But the number of miles, that might be something I have to think about. Well, it said in the very beginning there were 13,091 miles on the odometer, but when he returned it, there were 13,322. So I think however many miles he drove, it'd be the difference between those, right? If he started out with 13,091 and he ended up with 13,322, however many miles between them is how many he drove. So I think I'd have to subtract here. I'm going to have to borrow a little bit. 3, 2. All right, so it looks like 231. Oops. 231 miles, 14 gallons. Okay, I think that looks good. And these problems, I think what they want is, you can leave it like that, but I think what they would like you to do is change that to a decimal. So think of it as just one fraction. Now that we've set it up, that's 231 over 14. You can now say it like miles per gallon. But what if someone asked you, oh, that SUV you drove, what kind of gas mileage did it get? And what if you said, oh, it got 231 over 14 miles per gallon? What would they say? What the heck's wrong with you? Why would you say that? What the heck? Who talks like that? So what you'd probably want to do is divide these guys, make that into a decimal. So I'd have to go off to the side and try that. I'm going to try to divide 14 into 231, and I'm not too excited about this because I don't like long division, but whatever. All right, 14 can go into 23 once, or twice. No, once. If I subtract, I get 9. If I bring down that 1, ooh, how many times does 14 go into 91? Let's see, what's 14 times 4? 14 times 4, that's way too small. What about 14 times 8? 14 times 7? I think 14 times 6 might be the one. Let me try to see what that is. Yeah, I think that's as close as we're going to get. So 6 times 14 is 84. If I subtract those guys, I get 7. All right, I'm not getting a 0 denominator. But again, I think they designed these problems so that this decimal ends at a certain point. I'm going to bring down that 0. 14 goes into 70. Oh, it goes in evenly 5 times. Good. Whew. All right, that was a close one. So it looks like my answer is 16.5 miles per gallon. That's not that great, huh? But I think for an SUV, that sounds about right, probably. You're going to be spending a lot of money on gas, I think. All right, that's good. We got part A. Most of it was scratch work, right? Really the only work we had to show was this part right here. All this stuff over here was just kind of scratch work. Okay, how about part B? What are they asking there? They're saying, find the average cost of the rental in dollars per day. Okay, that means they're saying, let me write this down. Dollars per day. So remember, like we said, you're going to set up a fraction where the numerator has the first thing they mentioned, dollars, and the denominator has the second thing they mentioned, day, or days. Okay, so I'm going to look at the problem. How many dollars did he spend? Well, they said they charged him $92, right? There's not really anything I have to do. It's not like I have to subtract anything or divide anything. And how many days did he spend? Well, he got the car on February 10th, and he returned it on February 12th. So that's 2 days, right? Let's see. Yeah, that makes sense. Okay. So $92 over 2 days. Makes sense. Okay. So I think I can, if I want to, I think just writing the dollars and the days in the numerator and the denominator, that was just there to remind you how, what numbers to put where. But now that I have the numbers in place, I can think of that as another rate, dollars per day. And I'm going to divide those. 2 goes into 92 46 times. Dollars per day. Most people, though, would probably put the dollar sign, right? 46 per day. Now, that looks a lot better. All right, I don't think that's too bad, actually. Is that for renting a car? Anyway, I don't know. Okay, sounds good. All right. They want a lot of information here. What's part C now? Part C, they want to know what's the average rate of travel. They want miles per day. All right. So that's the key when they say things like that. Miles per day. That means I'm going to set up a fraction where the first thing they mention is in the numerator and the second thing they mention is in the denominator. And I just have to look back at the problem. How many miles did he travel? Oh yeah, remember we found that in part A. We did some subtraction and we said, oh, he drove 231 miles. So I'm just going to bring down that. I already did the work for that. 231 miles. And how many days? Oh yeah, we found that out before. 2 days. Whew. All right. I guess I should say days plural, huh? So that's 231 over 2. I think I can probably divide that. What's 2 into 231? Let's see here. 2 goes into 2 once, 2 goes into 3 once, with 1 left over. If I bring down the 1, 2 goes into 11 5 times, with 1 left over. So it looks like 115.5. 115.5 miles per day is the units they wanted. There we go. That's kind of quite a few miles, huh? But not too bad. All right, we're doing pretty good, I think, you guys. We're doing great. Good job, us. Let's see, in the last part, part D, I'm getting kind of tired of this problem, huh? Just kidding, but seriously. Part D, find the rental rate in cents per mile. Cents per mile. All right, that means I would like to set up a fraction where we have cents on the top and miles on the bottom. Cents per mile. Well, they didn't give us cents, but I guess they gave us $92, right? So if you have $92, how many cents is that? Well, since there's 100 cents in a dollar, you can multiply by 100. That's 9,200 or 9,200 cents. That's a lot of cents, huh? Now, it sounds like a lot, but that's $92. Okay, so we got the amount of cents. How about miles? Do we know that? That's right, we knew that. We've used that in part A and then part C also. So it was 231 miles that he went. Okay. Ooh, I don't know. Is that going to go divide in pretty? I don't know. I'm not too excited about that. You know what? I think that one doesn't go in evenly. Let's say, the problem like this, since it doesn't go in evenly, they would say something like round to the nearest tenth or something. They wouldn't mention that, say, in part C, because that decimal ended up stopping, we got a nice zero remainder. But in this one, I don't think we would, so I'm going to say, let's just divide that until we get to the 10th place. All right, well, let me see. I'm going to divide over here. 231 into 9,200. Ugh. Let's see, 231 into 920. 231 times 3? No, let's see, 231 times 4. I think that might be too much. How about 231 times 3? Let me try 4, just to see how that goes. 4. No. Oh, a little bit too big, huh? 924. Let's try 231 times 5. That'd be 5, 15. Wait, what? Oh, why'd I go up? Hello. I'm losing my mind. 3 times 1 is 3. 3 times 2 is 6. 3 times... Oh, wait. Oh, my gosh. 3 times 1 is 3. 3 3 times 3 is 9. 3 times 2 is 6. All right, I think that's as close as we're going to get. A 3, which would give me 693. If I subtract those guys, I get what? 227, because you have to borrow from this guy. Make this a 12. Make this a 10. Okay, that sounds good. Bring down the 0. Oh, that's going to be a lot. 231 might even go into 2,279 times. Let's see how that goes. 9 times 1 is 9. 9 times 3 is 27. Yeah, I think that works, huh? 39. Let's see. Point times that is 2079. If I subtract those guys, I'm going to have to borrow 16, 191. Okay, we're not getting a 0 remainder, but the next digit is going to be the 10th place, which is all they wanted, I think. So let's see. I'm going to try, I think it would be probably 8. Let's see. 231 times 8. 4, 2, 6, 9. I think that looks good. 8. 8 times 231 we just found was 1848. Although at this point, you know what? We should actually see what the next digit is, because I'm not sure if I should round it up from 39.8 to 39.9 until I see one more digit here. So I better get one more. Let me see. I have to subtract these guys. Borrowing 10. Okay, 62. If I bring down the 0, what's that going to be here? I think it only goes in twice. And then now that I see that, it's 39.82. The 2 is not big enough to round the 8 up, so it'd stay in 8. So it'd be 39.8, and I've already forgotten what the the units are. Oh yeah, cents per mile. That's right. Alright, so that's what kind of... That's good to know, huh? If you rent a car, I'd want to know how much am I paying per mile. That's good to know. Okay, basically 40 cents per mile, huh? Okay, that was kind of a painful problem. I think that was the worst one, don't worry, because I had 4 parts. The rest of these are pretty short. Okay, let's try this next one here. Example 2. What are we talking about? It says the U.S. federal budget debt was $8,612 billion in 2006, and then $15,041 billion in 2011. Let's find the average rate at which the debt was increasing. Ooh. Okay. This one's kind of tricky because you notice they didn't say, like in the last problem, how they said, find the rate, and then they told us the units, like, find the rate in cents per mile or in miles per gallon. On this one, they didn't tell us, so I guess I have to kind of figure it out for myself. The average rate at which the debt was increasing. So, well, the good thing is all they gave me was dollar amounts and years. So it's either going to be like this with dollars over years or years over dollars. So I have to think, which one sounds more correct? Do you usually hear people say the rate at which the debt was increasing was something dollars per year or something years per dollar? I don't think I've ever heard anyone say that. The debt was increasing at 5 years per dollar? That doesn't sound right. I don't think I could even... Someone told me what that is. I wouldn't even make sense of that. What the heck are you talking about? So I think it'd be in dollars per year. So it's how many dollars over the number of years. But let's see. And if you're thinking right now, okay, which dollar amount do I put in? Well, since they want the increase, I'm going to have to subtract them. That's what they're talking about. Dollar increase. Kind of like in that last example, it was when they said the odometer read this amount when he left, and it read this amount when he came back. You know, it changed, so we had to subtract. It's kind of like that. The more recent federal budget debt was $15,041. The older one was $8,612. I'm going to have to figure out the difference between those by subtracting first. That would be 15, 14. Okay, 6,429. So that's how much the federal budget debt increased between 2006 and 2011. And then in the denominator, they want how many years, how many years passed between them. From 2006 to 2011, how many years passed? 5 years, right? Because 2006 plus 5 is 2011. Alright, so we got the ratio down, but that doesn't really sound great. You know, if someone told me that, did you know that the federal budget debt was it increased at 6,429 in 5 years. I mean, I'd kind of want to know, how about per year? Every year I'd want to know. That's the last thing we're going to do, is make this into just one number by dividing the bottom into the top. Oh, this, I imagine just from the previous problems, this might take a while, so I might do this somewhere else where I have more room, huh? Let me see, where do I have more room? Maybe way over here. 5 divided into 6,429. 5 goes into 6 once, with 1 left over. 5 goes into 14 twice, with 4 left over. 5 goes into 42 8 times, with 2 left over. 5 goes into 29 5 times, with 4 left over. Oh, geez. Okay, one more. If I bring down this 0 by putting a decimal there, 5 goes into 48 times exactly. Whew. Alright. Good, that was a close one. It looks like this guy we can write as one nice decimal number. That's, what is it? $1,285.8 per year. That's quite a bit, huh? Oh, I said dollars, but notice they said in billions of dollars. I should say billions per year. Oh my gosh, that's a lot of money. Try not to get too depressed reading this problem, huh? But, so $1,285.8 billion per year is how much it increased between 2006 and 2011. Interesting. Alright, let's try this next one here. This one's not quite as entertaining. It's some person on an elevator. So, it says, it even gives us the exact time. Look at that. At 2:38 p.m. It's kind of creepy that someone knows exactly when this person entered the elevator, right? Laura entered an elevator on the 34th floor of the Regency Hotel. That sounds like the beginning of one of those crime dramas, huh? At 2:40, she stepped off on the 5th floor, never to be seen again. Or no, some creepy. It's getting creepy. I better stop. Sorry. I watch too much of those shows, huh? All right. Anyway, so they want 2 things here. First thing, they want us to find the elevator's average rate of travel. I like these ones where they tell me the units in number of floors per minute. Aha! Thanks, guys. So it'd be something, number of floors, because that's the first thing they mentioned, and then per minute, that must be what they want in the denominator. Alright, so I gotta look at the information given. How many floors did she travel? Well, you notice they said she started on the 34th floor, and she ended up on the 5th floor. So how many floors did she travel? That's 29 floors, huh? So she started at 34, she went down 29 to get to the 5th one. Okay, so 29 floors. That makes sense. Okay, and then how many minutes? Well, it said she stepped on the elevator at 2:38, and she stepped off at 2:40. That's only 2 minutes later. So it must be 2 minutes that we're looking for. Alright, and then that one I don't think will be too bad to divide, huh? It doesn't go in evenly, but once I make it a decimal, it'll work out. 2 can go into 2 once. It goes into 9 4 times. If I add a decimal and a 0, it goes into 10 5 times evenly. So, okay. 14.5, and what are the units? Floors per minute. That's pretty fast, huh, for an elevator? Or no, is it? Maybe not. If you think about, part of that time was probably her getting on and the doors closing and all that stuff, you know, pressing the buttons and the elevator having to think about where to go. That's not too bad, I guess. Okay, anyways, don't overthink it, right? Don't overthink it. Part B, what are we talking about? Oh, hello. I gotta see the problem here. They said they want us to find the elevator's average rate of travel in seconds per floor. Okay. This time the first thing they mentioned is seconds. And then they mentioned floors later. So it must be, they want seconds on the numerator and floors on the denominator. Okay, well they didn't give us how many seconds, but I know that 2 minutes is 2 times 60, since there are 60 seconds in a minute. 2 times 60 is 120 seconds, right? So if you think about that off to the side, 2 minutes times 60 seconds, that's 120 seconds. Okay, and floors, we already knew that from the last part. 29 floors. So we got 120 seconds for every 29 floors. And this one I think is not going to go in evenly. So let's say this is one where they'd have us round to the nearest tenth because it's not going to be pretty. To the nearest 1/10. Alright, let's see. I might, this always takes a lot of room, so I'm going to go off and try this over down here. Is that okay? It's, what are we dividing? 29 into 120. And I got to keep in mind, all I care about is the decimal point. I need 2 more digits after that if I want to round to the 10th. Okay, so 29 goes into 120. What do you think? 4 times maybe? Let's try that. 8, 19, okay, that sounds about right. 4 times 116. If I subtract those guys, I get a 4. I'm going to bring down another 0. Make sure there's a decimal in my answer. 29 can only go into 40 once. And 1 times 29 is 29. If I subtract those guys, I get 11. I need 1 more digit, so I'm just going to bring down 1 more 0. 29 into 110. Oh, that looks like it's about the same guy, huh? Oh, no, it's too big. Dang it. What about 29 times 3? 2, 8. Okay, 87. I think that's the one. You know what? At this point, it's like, I could go, oh, it's 3 times 29 is 87. But you know what? This is where it's, who cares? Because I got that digit I need. So now I know it's, okay, 4.13 about. And if I round that to the tenths, 3 is not big enough to round that 1 up, so it'll stay at 1, just 4.1. Alright, now we know that this is, our answer is 4.1, and then the units they wanted was seconds per floor. Oh, when you put it like that, that's not so bad, huh? This elevator goes down a floor for every 4.1 seconds. That's not bad. Wow, that really puts it in perspective, right? Jeez. Okay. We're almost done. This section is pretty good. I mean, the main thing that I don't like is all the tedious arithmetic that I have to do. That's the only thing. Let's see, this one, now this time, this last example, they're kind of bringing it back to graphs. They're saying, the graph below represents how many feet a snail traveled over a period of 4.5 hours. That's kind of cute. Oh, I think I messed this up. It should be, I put M here, it should be feet. Sorry about that. How many feet he traveled, and then time, that should be in hours. Sorry. Oopsie. Talking about a snail here, you know. Hello. He doesn't travel in meters per second. He travels in feet per hour. This guy is slow. Alright. So, at what rate did the snail travel? Ooh, okay. That's a good one, huh? So let's see. I guess what I have to do is kind of figure out, you know what I can do? Just say, how many feet did he travel? He or she, I don't know. He, she. I don't want to offend the snail. And how many hours did it take? Okay. And then I can set it up like a ratio. That'll be feet per hour, I guess. Because usually when you drive or something, we're talking about miles per hour. But this guy doesn't move in miles per hour. He goes slower, so it's feet, which is a smaller unit, right? Instead of per, and then it's per hour because hour's okay. It's just the feet. He can't go very fast. So it looks like on this graph, the horizontal axis is how long it took him. It looks like he started at 0 hours, so he kind of like started timing himself in the beginning, and at the end he went for 4.5 hours. So that's not too long. And then what he did was, how many feet did he travel? That's the vertical distance. So he started at 0 feet, and by the time, you notice that right here, by the time he got to 4.5 hours, he had traveled 9 feet. So it looks like he traveled 9 feet because he went from, if you look at this, the line, he went from 0 feet to 9 feet, and it took him 4.5 hours. Okay, and I think I can divide those guys, right? 4.5 into 9. Well, 4.5 can't go into 9, but remember before that trick, you can move the decimal over once to make that a 45. As long as I move 9's decimal over once, which would make it a 90. Actually, that's nice, because did you know 45 goes into 90 twice exactly? That's crazy! That's a nice number, 2 feet per hour. That guy wasn't going too fast. That's why you see a lot of snails that got stepped on, huh? Because they're trying to make a run for it, and they do not quite make it. Going 2 feet per hour. Alright, well, thanks for listening, and hopefully this all made sense. I think now that we've seen these rates, the next section will be a lot easier and make more sense. Okay, you guys, have a great day. See you at the next one.